everyone, welcome all to the next continuation of lecture series. We are discussing about the loss functions in deep learning. We already discussed about regression loss function, binary classification loss functions, hinge loss function, Huber loss function. In this video we will discuss about multi-classification loss function. Categorical cross entropy, often simply referred to as cross entropy, is a widely used loss function in multi-class classification tasks. Multi-class means it's not 0 and 1 different classes. It could be the severity of the cancer, right? So cancer stage 1, cancer stage 2, cancer stage 3. It is not only predicting whether the cancer is there or not. So it has multiple class. It measures the dissimilarity between estimated class probabilities and true class labels in a categorical setting. So CCE y cap is minus sigma I is equal to 1 to n yi log yi cap. So y cap means predicted value, as we saw. Y means actual value. So CCE y cap represents categorical cross entropy loss. Y is one hot encoded vector representing the true class labels. Each element of y is 0 except for element corresponding to the true class, which is 1. Y cap is a vector representing the predicted class probabilities for the data point. Multi-classification loss function. Kullback-Leibler divergence, KL divergence loss, is also known as KL loss, is a mathematical measure used in the machine learning and statistics to quantify the difference between two probability distributions. Here we have the formula KLPQ is equal to sigma P underscore I into log P underscore I slash QI, where KLPQ, this represents KL divergence from the distribution P to distribution Q. It measures how distribution Q differs from the reference distribution P. Sigma, this symbol denotes, of course, the summation typically taken over possible events or the outcomes. P underscore I and Q underscore I, these are probabilities of event occurring in the distributions P and Q. Log P underscore I slash Q underscore I, this term computes the logarithm of the ratio of the probabilities, two probabilities of the event I occurring in two distributions. It quantifies how much more or less likely event I is in distribution P compared to the distribution Q. So P is one probability distribution, Q is another probability distribution. So we are comparing how the distribution transfers or changes from probable distribution P to Q. That is what actually this loss is about. Multi-class classification loss function. In this we have sparse multi-class cross entropy loss function, often referred to as sparse categorical cross entropy loss, is a loss function commonly used in multi-class classification problems where the class labels are integers rather than one hot encoded vectors. The formula is loss is equal to minus log of y underscore y cap minus y. Y cap underscore y. Loss, this is the value of loss function for the given data point y cap underscore y. This represents the predicted probability for the true class y. So till now we have discussed about different loss functions, right? So what is a loss function? Loss function is to find out is there any error in a given neural network, whether the neural network is functioning properly or not. In loss function we compare basically the predicted outcome and the actual output right? So loss function is the function of predicted outcome and the actual output. So based on the classification techniques, there are different types of loss functions that we have discussed. We discussed about binary classification loss function, Huber loss, hinge loss, right? Then mean squared error, mean absolute error, and then we discussed about multi-class classification loss functions. The next video we will see about how we are going to implement the loss functions. Thank you.